Hello, my name is Farshid and I'm from Uppsala University. In this demo, I present to you ProFuN TG tool. This tool is a high-level programming environment for sensor network, and it provides you with many ways to simplify and ease the programming and your experience with your sensor networks. So this tool helps you with many aspects of sensor networks. This includes application design, deployment, and maintenance of the network. In terms of application design, we follow macro programming approach. That means you just have to design the application of the network as a whole instead of programming every node separately. This design is in terms of tasks and in terms of data flow among the tasks. The tool will take care of allocating tasks to the nodes in the network. And it provides you an interface for describing and simulating a model of your network. In terms of deployment, the tool allows to specify software configuration and hardware components of network nodes. And using this information, the tool creates the firmware image to be deployed on your sensor nodes. This tool also helps you with development of reliable application, and it's possible to specify quality of service requirement in the model. For example, you can specify a constraint on the packet delivery ratio. You can specify constraints on packet delay and energy consumption. So at the runtime, our network middleware tests the satisfaction of these constraints. And if the test fails, then it reallocates the tasks over the air. Before I start with an example, I would like to quickly show you some of the major technologies we use in our tool. In our documentation page, you can see the architecture diagram. We use G-code for constraint programming, we use Node-RED for the front end, and Contiki for middleware, and Kuja and MSP sim for node emulation and radio simulation. Okay, so let's create a simple indoor light intensity monitoring application. So for this application, first of all, I will clear all, and I would like to add an apartment image. So let's upload this apartment image for our background. This would be our deployment and physical environment. Then in the task sheet view, I will implement the application of this example. So the application would be a light intensity monitoring. So I will drag and drop a task, which is a light sensor. Then we would like to collect these data. So I drop a data collector task. And we create a data flow from light sensor to data collector. Okay, so now let's create the physical network. Here I have two choices, Sky Mute and Zolertia Z1 Mute. Sky provides us with light intensity sensors. So I'm going to use Sky, and I choose the sensor template for it. The template specifies the configuration of a network node. Then I simply copy and paste this node for every room in the apartment. Okay, before I start the task allocation and the simulator, I'm going to make sure that the light sensor would be running on every node in the network. So that would be frequency on each node. Okay, and you can see frequency per node. Then the data collector will also inherit from the upstream, which is going to be this. So now let's allocate, and you can see that we have one light and collect task per sensor. Then we can start the simulator also. Okay, now let's look at the Kuja simulator and see if our network is actually functioning. So here we can see the network, and here we can see it as the data being collected, and you can see the output for every node. So we see that it's working fine, and all the data is being collected at our gateway, which is the first sensor I placed. The tool also provides you with a graph of the data as it's being collected. Here are the 5 light intensity values, and you can see that these data are being collected. Of course, they are simulated at the moment. You can also look into our documentation for many tutorials and many advanced topics in this on how to use the tool. Also, please visit our ProFuN tool page and where you can find all the members in the project and all the publications. Thank you very much for watching the demo.